Hey everybody, in this video we're talking about addition and subtraction of vectors. We're going to look at two vectors today. We're going to look at vector u, which has a position of 5, 0, and vector v, which has a position of 3, 4. Now we're not using our normal notation just to make life a little bit simpler. We're going to use the bold lowercase letter, which is a perfectly acceptable way to write our vector notation, but it's not the common one that we have with the arrow over the two letters. Okay, so let's get to this. We're going to add these two vectors together. So let's start with our u. We have to draw our u vector, and that's moving 5 in the positive x, 0 in the positive, or 0 in the y direction, so we just have a horizontal line. Now we're going to do our v vector. So that's going 3 in the positive for x, 4 in the positive for y. And if we're adding these two things together, we're going to get the resultant vector of u plus v, which is just cutting across the diagonal there. Now, we could just as easily draw our v vector and draw our u vector, and we get a nice little parallelogram, and we should get the same result because if we are following u plus v, that should give us the same result as v plus u, whether we go in the v direction first and then the u, or vice versa. But let's check it mathematically to make sure that these two things are indeed the same. So if we take u plus v, we're going to have 5, 0 plus 3, 4. So we add those together and we get a result of 8, 4. And we count over across the x. We see that we're moving 8 in the positive. We count up. We got 4 in the positive. So that does indeed match. So let's check with vu. So vu, just to check it mathematically, you probably already figured this out. We have 3, 4 plus 5, 0, and that indeed is going to give us 8, 4, so these two things are the same. But what about subtraction? Subtraction is always a little tricky, so let's see if this works out the same way. So we're going to look at u minus v and see what does that produce for us. Well, let's start with our u. We're going to draw that vector, and that's our 5 in the positive, 0 in the 5 in the positive x, 0 in the positive y. I keep on saying positive y. 0 in the y direction. And then we have our negative v. So we're subtracting v. So we're going in the opposite direction than what we did before. So we got our minus v. So our resultant vector is going to be when we cut across there. So we've got u minus v. So let's see what happens. We got 5, 0 minus 3, 4, and we get 2, negative 4. All right. Well, if we count that over, let's check to make sure that that works. We're going 2 in the positive x, down 4 in the y, so a negative y. So yes, we've got the vector 2, negative 4. So does u minus v equal v minus u? That's the big question here. Is it going to work both ways and still come up with the same vector? Well, let's try it. So we've got our vector v. Now we've got to do minus u, so we're going to be going in the opposite direction for u. So we're going backwards 5 into the negative 5. And we have our resultant vector v minus u. Alright, so let's work this out and see what we get. V minus u is going to be 3, 4 minus 5, 0. And as we subtract these two, we get negative 2, 4. So are these two things the same? Then we have the answer no. Clearly they are not the same. They are collinear, they are parallel, they do have the same magnitude, but they are not the same vector. They don't have the same position vector as the addition does. So whether you have u plus v or v plus u, you end up getting the same resultant vector. But if you have u minus v or v minus u, you don't get the same vector, but you do get parallel vectors, similar magnitudes of vectors, and so on. So I hope this helps with your addition and subtraction of vectors and getting some ideas behind this, and we'll talk to you in the next video.